So this question is already in factor form. So we have a degree of 1, degree of 3, degree of 2. So the total degree of 6. So our degree is 6. Our leading coefficient in this case is -2. So we have a negative leading coefficient, which tells me that my graph falls on the left and falls on the right. We just need to figure out what's happening in between these two end behaviors of our graph. So like the previous examples, I'm going to do a chart with my zeros, my multiplicities, and my end behaviors. So I have, for the x minus 2, I have a 0 at 2. For x minus 3 cubed, I have an x equals at 1. And the last one is x equals -2. Since it has a power 1 for x minus 1, right here has a power 1. That means it's a single, a triple, a double. So I have a single for x equals 2. For x equals 1, I have a triple. And for x equals -2, I have a double. The single lets me know that it crosses. So it looks linear. So one more time, it looks like a line. A triple crosses. And it looks like a cubic. So something that looks kind of like that. And the double bounces. And it looks more like a quadratic. So something like that, or vice versa. So I'm going to put my points. So I have a point at -2, one at 1, and one at +2. At -2, I know that my end behavior starts down here, and when it gets to -2, we know it bounces, so it's going to touch it and bounce. And then I know our next one is going to be that 1, and it's triple, and it's going to cross, looking more like a quadrat, like a cubic. So something that looks like this, and hopefully you guys do a better job than I do. And then at 2, it crosses and looks linear. So something that very similar to that. Then we know that the number of relative maxes, we're going to need to find that, and the number of relative mins. So our relative max, to see how many we have 1 here, we have 2, so we have 2 relative max, and we have 1 relative min. So 2 relative max, 1 relative min. This one problem, we need to factor out, and since it's a binomial, we're going to see if we can factor it a greatest common factor. So we're going to have f of x is equal to, take out a -2, x squared, and we're going to get x squared minus 1. We could factor further, and now we have -2x squared, x plus 1, x minus 1, because that's a difference of 2 squares. We could go back and identify our degree. Our degree for this function would be 4, and our leading coefficient would be negative. So that means our graph, again, falls from the left and falls from the right. So for our table, we're going to have our zeros, our multiplicities, and our end behaviors. So we have a 0 at x equals 0. We have 1 at x equals -1, and 1 at x equals +1, because we're using the zero product property to solve this polynomial. So we have a double for the 0. For the -1, we have a single. And for the positive one, we also have a single. That means for the double, it's going to bounce. Then we're going to cross. And we're going to cross. And all of these crossings, our linears and the bounce again, are more quadratic looking. So we're going to plot our points. We have 0, -1, +1. And we know that our graph is falling on the left. And at that -1 is going to cross. At that 0, it's going to bounce and going to cross again. So it should be something that looks very similar to that. Then we have a number of relative maxes and our number of relative mins. So relative maxes, we have 2. We have 1 here and 1 there. And the min, we have 1. So we have 2 relative max, 1 relative min. For this problem, they're asking us to find a polynomial function with a 0 at -2, 1, and 3. Okay, we're going to write it in factor form, and then we're going to distribute and write it as standard form. So since these are our zeros, we know if we write it in factor form, we're going to have x, it's going to be the opposite sign, so it's going to be x plus 2. And the opposite of 1 is x minus 1, and the opposite of 3 is x minus 3. So we have, this is our polynomial in factor form. So the reason we did that, remember, when you solve for this, is always going to be the opposite. So the opposite of 2 is that -2. The opposite of -1 is that +1. The opposite of -3 is that 3. It's when we're solving. Remember, we do opposite operation to solve because we're using the zero product property. So now that we wrote it in factored form, we're going to distribute and we're going to write in standard form. So first we're going to work with the first two binomials. So we're going to have this times this and so forth. So we're going to have f of x is equal to x times x squared. So that gives us that. X times that is -x. This one times that is 2x. And then we have a positive -2. We could combine because now we have this minus times that. We could combine this right here and we could make it a positive 1x if we don't want to rewrite the whole thing over. And then we're going to now distribute this trinomial times the binomial. So we're going to have, you know what, just because, let's just rewrite it. It just makes it easier to understand. X squared plus 1x, or x, minus 2 times our x minus 3. And now we're going to distribute. So now we have f of x is equal to x cubed. That gives us a -3x squared. Now we're going to do the bottom. This number times that number. Positive x squared. That times that is -3x. The next one, I'm going to do a different color. -2 times that, it is a -2x. And -2 times that is a positive 6. Now we combine our like terms if we have any. And let's see, we have a cubed. We could combine these two together. We could combine those together. And then we're going to have f of x is equal to x cubed minus 2x squared minus 5x plus 6. And this is our polynomial in standard form with zeros at -2, 1, and 3. So I know that this polynomial looks a little bit more complicated, but honestly, it's the same process. We are going to write it in factored form. So we're going to have f of x is equal to x minus our x plus square root of 3. That is one number. Then times our x minus, because it's going to be the opposite. 6 minus square root of 3. I suggest that you distribute that negative in there just to make it easier and less chance of making mistakes. So I'm going to have x minus 6 minus square root of 3, x minus 6 plus square root of 3. And then we're just going to do what we did before. We're going to distribute. So we're going to have x times x is x squared. X times that is negative 6x. This one times that is going to be plus x squared root of 3. This one times that one is negative 6x. Negative positive 36. This one times that one is negative 6 squared root of 3. And then our last one right here, this times that one is negative x squared root of 3. Positive 6 square root of 3, and a negative square root of 3 times a positive square root of 3 is just negative 3. And now we combine our like terms if we have anything, or eliminate things that go away. So this goes away with this one. This goes away with that one. They cancel each other out. We combine these two and we combine those two. So our function with zeros at x6 plus square root of 3 and 6 minus square root of 3 would be x squared minus 12x plus 33. This would be our polynomial function in standard form with zeros at 6 plus square root of 3 and 6 minus square root of 3.